Hello, in this video, I will explain to you on how to solve this problem. Number 10, figure 6.9 shows an initially stationary block of mass M on the floor. A force of magnitude 0.5 mg is then applied at upward angle of theta 20 degrees. And the question is, what is the magnitude of the acceleration of the block across the floor if the friction coefficient are given? Okay. Let's use this coordinate system here. We will have our x and y there, right? Because we are given this direction here, x positive is to the right and y positive is to the top, right? So it is like this here. And then let's draw what is the forces that works on the block. Okay, the obvious one is the weight of the block here. And let's name that the force of the weight here. So I will have the Fw, and then the force that is worked by this floor on the block, and that is the normal force, right? So we will have N here, and that will be upward. So that is the normal force, Fn. Good. And then we have this applied force, the blue one here, and we have this has an angle of 20 degrees. So we need to project it into x-axis and also on the y-axis. Okay, let's do that. On the axis here, I will have this force here, and let's name this as Fx. Okay, and then what is the value of Fx? Let's see here. This is the hypotenuse and this is the adjacent side. Adjacent and hypotenuse is cosine. So I will have F cosine theta. And obviously in the vertical direction, it will be F sine theta, right? So we will have this going up here, and we have Fy, and that Fy is F sine of theta. Good. And then the force of the friction here is the opposite of the movements here, because this F is here, the movements will goes there, right? So we'll have the movements, and so the force of the friction will goes to the opposite of the movements. So I will have this force of friction. So I will have F here, and that will be mu times Fn. However, we have to know what the value of Ff and Fx here. Which one is greater? If Ff is greater than Fx, then the block is not moving, right? But then if Fx is greater than Ff here, then the block is moving. Okay, so now let's calculate this Fn first, right? Because we need to use it to calculate the frictional force. Okay, now let's do it on the y direction. So I will have sigma F on the y direction is equal to the mass times acceleration, but also in y direction. Okay, let's see here. The block is not moving on the y direction, right? It's not flying or it's not falling, right? So in the right hand side, I will have this is equal to 0. Good. Now in the positive direction, I will have the normal force Fn, and then I also have this Fy here. But then on the negative direction, I will have the force by the weight. So I'll have Fw here. And all of that will equal to 0. And I think I can isolate Fn here. So I will have Fn that will equal to Fw minus F sine of theta. And then let's plug that in, right? So I will have Fw that will be the mass times gravity, and then minus F is 0.5 mg. So I have 0.5 mg And then we will have sine of theta. What is theta? Theta is 20 degrees. So I have sine of theta, 20 degrees. And we can take out this mg here. So I have mg, then multiply this by 1 minus 0.5 sine 20 degrees. Okay, I think we can just use calculator for that. What is the normal force here? Where is my calculator? So we will have 1 minus 0.5 multiplied by sine of 20 degrees. So I'll have 0.83. 0.83 multiplied by mg. So that is our normal force here, and that is one of the most important values. Okay, let's clean up our slide here. Okay, now let's calculate this fx here, because that is also an important value. So what is our fx? Fx here is f cosine of theta. And f here is 0.5 mg. So let's plug that in, 0.5 mg. And then cosine of theta. Theta is 20 degrees. So we will have our fx here. What is our fx? Let's see here. 0.5 multiplied by cosine 20. That will be 0.47. Okay, 0.47 mg. Good. And that is also an important value here. And then let's see here. Let's see for question A. Okay, we need to calculate the frictional force. But we have two cases here, right? When it is not moving or stationary, and when it is moving, or we use this mu k here. So ff when stationary. Okay, and that will be, what is it? 0.6. Okay, 0.6 times Fn. So I have 0.83 and then mg, right? So we will have mg. And so we will have 0.6 multiplied by 0.83 here. And that will be 0.5 mg. Okay, 0.5 mg. But then when moving here, the frictional force when moving, that will be 0.5 multiplied by 0.83 mg, and that will equal to 0.5 multiplied by 0.83. Okay, and I will have 0.42 mg. Okay, now let's see here. Because the horizontal force here, 0.47 mg, is not greater than this, so this force cannot push this block against the frictional force. So I will have for the question A here, the acceleration will be equal to 0, right? Because the block is not moving. Because this fx here cannot overpower this frictional force, right? So that will be 0. That is the answer for question A. Okay, now let's do again for question B. Okay, now let's do same game here for question B. So the frictional force when it is not moving, that will be, what is it? 0.4 multiplied by 0.83, and that will be mg, right? So I'll have mg, And that will be what? 0.4 multiplied by 0.83. So I'll have 0.33 mg, 0.33 mg here. And then the frictional force when it is moving, we will have 0.3 times 0.83 mg. And so we will have 0.3 times 0.83. And so we'll have 0.25 mg. Good. And now the block is moving. Why? Because this horizontal force is greater than the frictional force when it is not moving, right? So we have an acceleration here going to the right. So we will have to use the Newton's second law here. Sigma Fx is equal to mass times acceleration. Good. And on the right hand side, I will have Fx here, and Fx is 0.47 mg. However, because this is moving, we use this value here, 0.25, right? So I have minus 0.25 mg. And that will equal to the mass times acceleration. Okay, and we can divide both sides by the mass here. And so we can just calculate that, right? So I'll have the acceleration is 0.47 multiplied by g, which is 9.8, and then minus 0.25, also multiplied by g, 9.8. Okay, and all we need to do is plug this into calculator. So I have 0.47 times 9.8, and then minus 0.25 times 9.8. Okay, and I will have 2.16. Okay, 2.16 here, and meter over squared second. And that is our acceleration here for question B. So for A, it is not moving, and then B, it moves with the acceleration of 2.16 meter over square second. And that's all for this problem. Thank you for watching, and see you in the next video. Bye bye.